If you are new here, quick context. This is the second half of a map I've been building of what actually goes wrong in the body after COVID. Not theories, not wellness advice, just the mechanisms researchers have been able to measure. Last time covered the immune side, an immune system still switched on months later, the possibility that fragments of the virus never fully cleared, and old dormant virus that may have woken up while your body was busy elsewhere, probably fighting COVID. All three come down to the same thing. Your immune system is still dealing with something long after you were told you'd recovered. Today is different, and honestly, it's the harder half to sit with because the next 5 are less about your body fighting the virus and more about your body doing damage to itself. Systems built to protect you running in the wrong direction. And the first one is the clearest example of that there is. Fourth system, autoimmunity. Fourth, autoimmunity. And like the next one, I want to flag up front that this is contested. Antibodies are the proteins your immune system makes to target specific threats. That's normal and good. Autoantibodies are when your immune system makes antibodies that target your own tissue instead. The theory is that after an infection, some people's immune systems get confused and start treating their own cells like the enemy. The evidence genuinely cuts both ways here. One of the largest immune profiling studies out of Yale found no measurable autoantibody differences in long COVID at all. But there are other labs that have taken the antibodies from long COVID patients, injected them into mice, and watched those mice develop pain sensitivity and coordination problems that mirror what the human donors reported. The second result is much harder to explain away. If you transfer the antibodies and the symptoms travel with them, that's pointing at something causal. So, where does that leave us right now? Nobody has found a single autoantibody that shows up reliably across a large group of patients. And there's no agreement yet on whether these antibodies are actually causing symptoms or whether they're just showing up alongside them without doing much. But I don't want to wave off those mouse experiments because they're doing something the other studies can't. If you take antibodies out of a patient, put them into a healthy animal, and that animal starts developing the same problems the patient has, that means the antibodies are doing the work. That's about as close to cause and effect as you can get. Now, that's not proof it's happening in everyone with long COVID, and honestly, it's probably a smaller group, but in that group, it's hard to explain any other way. And this is one of the few places on today's list where the biology points at something you could actually do about it. Because if antibodies are causing the problem, then pulling the antibodies out of the blood should help. And that's not hypothetical. It's a real procedure that already exists for other autoimmune diseases. It's being tried in long COVID right now. Whether it works is still an open question, but at least it's a treatment aimed at a mechanism instead of a guess. System 5, microclots. Fifth, and this one gets enormous attention online. Microclots. Some researchers have found tiny clots, far smaller than normal blood clots, made of a protein called fibrin in the blood of some long COVID patients. What makes them unusual is that they resist the normal process your body uses to break clots down. They don't clear the way they're supposed to. The theory is that these combined with the damage to the lining of the blood vessels themselves could make it harder to get oxygen delivered efficiently to tissue throughout the body, which would explain a lot of symptoms at once. I want to be upfront though. This is actively debated and not just at the edges. Other labs have had difficulty replicating some of the findings, and there's real disagreement about how to measure these things reliably. It's a serious line of investigation, and it is not settled science. And you should be a little suspicious of anyone presenting it as though it were. System 6. Dysautonomia. Sixth, dysautonomia. Big word. Let me break it apart. Your autonomic nervous system is the part that runs things automatically without you thinking about them. Heart rate, blood pressure, digestion, body temperature, all happening in the background while you get on with your day. Dysautonomia just means the system is misfiring. And one specific version that some long COVID patients develop is called POTS, postural orthostatic tachycardia syndrome. Here's the actual definition, because it's far more useful than the general vibe of it. Your heart rate goes up by at least 30 beats per minute within 10 minutes of standing up, 40 if you're a teenager, and critically, without your blood pressure dropping. That last part is the piece I want you to hold on to because it's where people get dismissed. A lot of patients get told their blood pressure looks fine and walk out thinking that rules this out. It doesn't. Normal blood pressure alongside a racing heart rate is the pattern. It's not the exclusion. System 7. Mitochondrial dysfunction. Seventh, mitochondrial dysfunction. Quick refresher. Mitochondria are the structures inside your cells that produce energy. You might remember powerhouse of the cell from school. That's them. This one has some of the most direct physical evidence on the entire list. And it comes from a study out of Amsterdam that I think about a lot. Now, to understand what they did, you need to know about one specific symptom because it's the one they built the whole study around. A lot of people with long COVID describe something like this. They do something ordinary, not a workout, just a trip to the grocery store or an hour of work or a shower. And at that time, they feel more or less okay. But then the next day, they can't get out of the bed. The exhaustion is total. Their whole body aches. They can't think straight. And it can last days. So the punishment doesn't come while you're doing the thing. It comes a day later. And it's completely out of proportion to whatever you did. Doctors call this post-exertional malaise. Patients usually just call it a crash. Post-exertional malaise. And that delay is what makes it so hard to explain and honestly, so easy to dismiss as well. If you feel fine during the activity and terrible the next day, it's very easy for someone to tell you it's deconditioning or anxiety or that you're just out of shape. So, the Amsterdam group went looking for what's physically happening in the body during that crash. So the group from Amsterdam took long COVID patients with post-exertional malaise and put them through a maximal exercise test and then took muscle biopsies before and 1 day after. In the patients, the energy producing capacity of the muscle was already lower before they exercised at all. And it got worse afterward. They also found actual tissue damage in the muscle. So when someone describes fatigue that doesn't match how they're actually doing, and a crash the next day that feels wildly disproportionate, there is now tissue level evidence of something physically happening in the muscle. Not a feeling. It's with a biopsy. That study did draw published pushback, mostly about how fast those changes could plausibly appear and what it means for exercise advice. So, it isn't the final word, but it's a great deal more concrete than some research suggests. System 8, gut microbiome disruption. Eighth, and this one ties into work I've done a lot of, gut microbiome disruption. Your gut is packed with trillions of bacteria, and many of them aren't just sitting there passively. They're actively involved in regulating inflammation and immune function throughout your entire body, including your brain. Researchers keep finding that certain helpful bacteria show up depleted in long COVID patients. One in particular comes up again and again: Faecalibacterium prausnitzii. It's a butyrate producer, meaning it becomes a compound that helps keep inflammation in check. In one prospective cohort, people with ongoing symptoms still had it depleted 6 months out, while the people who recovered had their gut composition normalized over the same stretch. The honest caveat here: a lot of the early data came from hospitalized patients, many of whom received antibiotics, and antibiotics can reshape the gut on their own. So some of the signal is confounded. That doesn't erase the finding. It just means the cleanest evidence comes from the studies that controlled for it. I'm going to come back to this in a big way later. It will have a series on its own because I think it's the most underrated piece of this entire picture. So let's bring it together. Okay, let's zoom out. Immune dysregulation, viral persistence, reactivated latent viruses, autoimmunity, microclots, dysautonomia, mitochondrial dysfunction, gut microbiome disruption. Now, notice something about that list. They're not 8 equal siblings. Viral persistence and reactivated viruses are candidate starting points, the thing that kicks it all off. Immune dysregulation, autoimmunity, and microclots are what the body does in response to it. Dysautonomia and mitochondrial dysfunction are closer to what you actually feel: the racing heart and the crash after the grocery store. So it's less a list of 8 competing theories and more like a chain or several chains with different entry points. Which brings me to the point where I actually want you to walk away with. These aren't 8 theories where one is right and the other 7 are wrong. A real patient might have 2 of these things going on, might have 4, might have a completely different combination than the person sitting next to them with the identical diagnoses on paper. That's why I keep saying long COVID isn't one disease. It's a label we're using for a set of different underlying problems that all look similar from the outside. And it's probably a big part of why the trials keep coming back null. If you enroll everyone who carries the label and only a third of them have the specific mechanism your drug targets, you'll measure nothing, even if the drug works. That's also the hopeful part. Once researchers can identify which combination a specific person has, treatment stops being a guessing game and starts being targeted. That's the entire idea behind biomarker research, and it's why this matters beyond being interesting. I will talk about that as well. So that's the map. 8 systems, different combinations in different people, one label called long COVID doing far too much work. And from here, we're going to take them one at a time, properly, starting with the immune system, which is what we're doing in this series. But I want to be honest with you about something before I stop. Even this map isn't the whole picture. Everything I walked you through today is essentially the immune and biological angle. What COVID can do to organs and tissues directly, and what people are left living with afterward, that's an entire series of its own. And it's not this one. So, this isn't everything, it's the map. And now we start working through it one piece at a time. All right, let's open it up for questions.